Alright, so we just did arithmetic sequences where you added and subtracted the same amount each time. So geometric is multiplying the same amount each time. So we had a common difference for arithmetic. We're going to have a common ratio for geometric. So the common ratio you can find from your second term now divided by your first term. So your common difference was second minus first. This is second divided by first. Okay? If you're looking at it, 1, 5, 25, 125, you can tell you're multiplying by 5 each time, so R would equal 5. Okay? Now if you get smaller, so if it were going in the reverse, if I was doing 25, 5, 1, you would not tell me R is equal to divided by 5. So I've seen that before with... Yes, it'd be 1/5. I've seen that before with Algebra 1. So you can recognize that you're dividing by 5, but that's not what your R is. Your R would be 1/5. Okay, so make sure you understand the difference there. When you're getting smaller, you're going to have a fraction for your ratio. Okay? So if I have pretty much the same thing, 625, 125, 25, 5, 1, I did not even see that when I was writing this. Here, your common ratio is 1/5. If you didn't know it, then you would take second divided by first. That would give you 1/5. Then to confirm it, because here you're basically determining is it geometric or not. You're not telling me what is the common ratio between the first two terms. I need to go all the way through. 25 divided by 125 is 1/5. 5 divided by 25. So I just keep going like we did with the common difference.
Do all 4 of them?
Whenever it is asking you to determine, yes. But on a normal, when you're writing a rule, no. Because this is the work for you to show that it is geometric. So because all of the common ratios are 1/5, it confirms that it's geometric. So when I'm asking you to determine, yes, I want to see you prove that it's geometric.
I thought you were able to do the bump things instead.
So on here, if y'all are dying to not show work, then whatever. Okay? But you better show me that. All right? Either show me this or that.
Okay, because that's what I was doing.
Okay? If you show me nothing, there's your points off. All right, your rule. Your formula for geometric, AN is still your nth term, A1 is still your first term, R is your common ratio, N is the specific term. We write it actually with parentheses around your R. Doesn't matter if you do lowercase or uppercase. My R's, if y'all have not figured out by now, are always going to be capital. Y'all have had me all year. Y'all have probably noticed that. So it doesn't matter if it's, how you write that, but it's in parentheses when we write it. Okay, and the n-1 is your exponent. So arithmetic was linear. It represented a linear sequence. Geometric is similar to exponential. Okay, so your graph, if you were to graph the points on an exponential function and you were to graph a geometric sequence, they would look the same. Okay? Here, write the rule for the nth term of a geometric sequence with the first term of 3 and a common ratio of 2. So, first term, that's my A1. My common ratio is my R, that's 2. So my equation is AN is equal to 3 parentheses 2, close parentheses, and minus 1 is my exponent. No extra work, no nothing. So if I give you the first term in your common ratio, hopefully you can plug it into the formula because you're not getting partial credit. Okay, it's either you got it or you didn't. There's no work to be shown. Okay. Here, write the rule for the nth term of the geometric sequence, then find A7. I've got to do my ratio formula. So second, negative 76 divided by first, 152. Negative 76 over 152 is what? 1/2. Negative 1/2. Okay, you see how it's alternating negatives? Anytime that you see a sequence that's alternating negatives, more than likely it's going to be geometric. Okay, it'll never be arithmetic. So that's a hint if I tell you determine if it's arithmetic or geometric. If you see that it's alternating, it will never be arithmetic. That would mean that you're subtracting, then you're adding, then you're subtracting, then you're adding, if you think about what positive and negatives are. Okay? So here's my common ratio. My A1 is 152. So my equation, AN equals 152 times negative 1/2 raised to the n minus 1 power. Okay, then find A7. That means I'm plugging 7 in for n. You can type that in your calculator exactly as you wrote it. So 152 parentheses, get your fraction template up, negative 1/2 raised to the 7 minus 1. Okay? If it gives you this, the down arrow means it's not in simplest form. Keep hitting simplify until that arrow goes away. Now I have a mixed number. I don't want a mixed number. What is 2 3/8?
19 over 8? Right?
19. Yeah. So if you didn't know it, second and then hit that button with the mixed number. There's your improper fraction. Now, if you typed this in with a decimal, 152 times negative 0.5 raised to the 7 minus 1 spits out a decimal. Okay? So, whichever you want to do, I'm good with whatever. Okay? As long as you get it right. You understand that? One term of the geometric sequence is A4 equals 12. The common ratio is 2. Write the rule for the nth term. So A4 equals 12 tells me my AN, and it tells me my N is 4. And I also know my common ratio. What am I missing? A1. So that's what I'm going to solve for. So I'm going to have 12 is equal to A1 times my ratio of 2 raised to the 4 minus 1 power. Okay, well, 2 raised to the 4 minus 1 is just 2 to the third. What's 2 to the third? 8. So 8A1. Alright, I want to solve for A1, so I'm going to divide by 8. A1 is equal to what?
Give me one. 3 halves.
Should be 3/2. You can simplify them both by 4. Okay? So if my A1 is 3/2, my equation is AN equals 3/2 parentheses 2 raised to the n minus 1 power. You all good with that? Okay. Now, what if I give you 2 non-consecutive terms from the sequence? Okay. Last class, we had to write a system. You're doing that also. Alright, so A3 is equal to negative 48, and A6 is equal to 3072. So negative 48 is equal to A1. I do not know my R, but I do know my N is 3 minus 1. Well, I can clean that up. That is negative 48 equals a1 times r to the second power. I'm going to do the same thing for a6. So I've got 3072 equals a1, I don't know, r, I don't know, but I do know it's 6 minus 1. So when I clean that up, 3072 is equal to a1 times r to the fifth power. So the easiest thing to do is solve for your a1 by taking either one of those equations and dividing it by your r raised to whatever exponent. Okay, so here a1 is equal to negative 48 divided by r squared. Y'all follow me? I'm going to take this a1 and I'm going to plug it into the other equation. I'm going to substitute. So I have 3072 is equal to, I am taking negative 48 over r squared and multiplying it by r to the fifth. So that is going to give me negative 48 r to the fifth over r squared.
So negative 48 r to the third.
So if you remember your exponent rules, if I have a to the m over a to the n, that is a to the m minus n. I'm subtracting my exponents. So 3072 is equal to negative 48 r to the third. I need to solve for r. So I divide both sides by negative 48. R cubed is equal to Then what am I going to do? I'm going to take the cube root of both sides. Pay attention that that's a cube root, not a square root. If you put a square root there, yes, you're going to get points taken off, even if you got negative 4 as your answer, because you're not paying attention to what you're writing down. Okay? So it's the cube root, and r is going to equal negative 4. So what am I going to do with this r equals negative 4? Yeah.
Plug it in.
Plug it into one of the, you can either plug it into one of the original equations, but I've already solved for a1. So as long as you know you solved for it correctly, you can just plug it back into that. So I have a1 is equal to negative 48 over negative 4 squared. Make sure that your r is in parentheses. I have a negative for my ratio. I need to make sure that's in parentheses when I square it so that you don't have a sign mistake. Alright, so this is going to be negative 48 divided by 16. A1 is equal to what? Negative 3. So AN is equal to negative 3 times negative 4 raised to the n minus 1. Y'all okay with that? You don't have any questions? Okay, geometric means. That is just referring to the missing terms between two non-consecutive terms, just like with an arithmetic means. Okay, so this is my A1. This would be A2, A3, A4. 2,125 is my A5. So I'm going to have 2,125 is equal to my A1, 3.4. I don't know my common ratio, but I do know my n is 5 minus 1. So then 2125 is equal to 3.4 r to the fourth. Divide by 3.4. R to the fourth power is equal to 625. So to solve for r, what am I going to do?
Root 4? I don't know how to say
The,
that.
the fourth root.
Okay.
You can take the fourth root. Now, do you remember what happens when you take the even root of a positive number?
Plus or minus.
Plus or minus. So this is really plus or minus 5. Okay, so what you're going to have to do is find the arithmetic means when your common ratio is positive 5, and then find the arithmetic means whenever your common ratio is a negative 5. Okay, so if r is equal to 5, I'm going to have 3.4, and then my 3 missing terms are going to be what?
85, 45.
And if it's negative 5, this is the same thing except 17 and 425 are Swift.
Yeah, so if you have if you have a common ratio of a negative, then that means you're going to have alternating negatives. So that's going to be a negative 17, a positive 85, and a negative 425. Because really, either way, you can start with a 3.4 and end with a positive 2125. You don't know without it specifying if it's positive or negative. So if you end up getting an even root right here, make sure that you find the means for both positive and negative ratios.
Quite unfortunate how we can't just fill in the blanks on that one because it's two separate ones.
So are y'all good with that? Alright, so next class is when you're going to have a quiz over arithmetic and geometric.
Makes sense.
Okay?
Because they're